Guys, welcome to this video. We are just continuing our discussion on endogeneity. We have discussed the two different sources of endogeneity. In the first video, we talked about omitted variable. Then in the following video, we discussed about how to detect measurement errors. Finally, in this video, we are going to end the endogeneity detection in Stata using reverse causality. What does it mean by reverse causality is that when you have set up a model that has a dependent, independent, and control. So let's ignore the controls. The independent variable that you have set up with and you are showing through your OLS that it is having a significant or whatever impact on dependent. How do you prove that the dependent is not having an impact on the independent variable? If it happens, it will have some impact on the error terms and that will cause biasness in your study findings. There are many ways you can deal with this, and you can, one way in your paper, what you can do is you can provide theoretical arguments, the past findings that might have indicated some sort of causality in the reverse direction. That means, for example, you are in this case, for example, I have return on asset as a measure of profitability and is a dependent here, ROA, visualize variable. So let me just go back and bring my do file. If I run the simple regression, let me just run my full OLS like this, execute. And here you see that's what my model looks like is sustainable reporting is having an impact on the firm's profitability. That means the results indicate the more people reports sustainable information, they are getting more profit, becoming more profitable. However, the opposite hypothesis can also happen. That means profitable firms are the one who is reporting more information about sustainability in their accounting reports. How you can say that it's not correct? So you can provide a theoretical justification of this reverse causality, or you can actually perform some test. In Stata, you can perform some causality test using the panel data. So make sure, first of all, before you run, you have the xtset command is clearly identifying your number and year, and it will tell you that this data is strongly balanced. The stage that I'm going to run is going to be a bit problematic if your data is not balanced. If it is not balanced, if it is unbalanced, there might be some workaround. I'll try to find it, but just at this point, just for understanding, we are just going to run uh, the causality test using this strongly balanced data set. To run causality, you have to go for xtgcause. I'll put this command in the description, and you will have to specify what are the causality variables you want to specify. So as I want to see whether there is any evidence of reverse causality, I will just put my independent over here and the dependent over here, and I'm going to hit enter, and it has run. So you can see the xtgcause command has run the Domitricchio and Herlin 2012 Granger non-causality test, which is the null. And if the p-value is showing that you can accept the null, that means ROA does not Granger cause standard sustainability reporting. So in this way, you can confirm that there is no reverse causality evidence in this data set. I hope you find this useful. And if you want to know more about granular causality or about reverse causality, how does it affect endogeneity and how having a reverse causality can make an impact in your baseline results with Cool OLS, feel free, put your comment in the chat box. I'm happy to create a video explaining whatever I understand about this issue. But at this point, I'm just trying to show you simply how you can run all these small tests and improve your writing, your paper. It's going to add those decorative features in the paper, and hope you will be able to push it further higher from ABS or ABDC bottom rank to higher rank. If it helps, that's the only thing I actually want at this moment. Hope you enjoyed the video. You have a wonderful day. Bye.